In this module, we will see how to operate the engines during the various phases of a flight and familiarize you with their functions and indications. On ground, thrust control is entirely conventional. The thrust lever position determines the thrust. The thrust levers can be moved manually over the entire quadrant. They never move automatically. There are 4 detentes on the quadrant: idle, climb for maximum climb thrust, flex MCT, 1 detente for 2 functions. Flex is used for reduced thrust at takeoff. MCT, for maximum continuous thrust, is used for single engine operations. Takeoff go-around, for maximum takeoff or go-around thrust.
Reversers are controlled using these 2 levers. Idle is the first position, and maximum reverse is the second. Thrust control can be achieved in 2 ways. Manually, using the thrust levers, as on any conventional aircraft, and automatically, when the auto thrust is active.
Let's look at the indications for takeoff.
On ground, with engines running, the thrust limit mode is takeoff go-around or flex. The selected mode is displayed in the upper right-hand corner of the engine warning display. Takeoff go-around represents the maximum thrust available from the engine for the actual outside air temperature, OAT. The corresponding EPR rating limit is displayed immediately below the selected mode. Flex is used for a reduced thrust takeoff. To achieve the thrust reduction and assumed temperature, or T-flex, is used, like for example 45 degrees. The flex temperature is displayed beside the EPR rating limit. This means that the engines will perform as if the takeoff was made at full power, assuming the outside temperature is at the flex temperature value. As a result, the actual takeoff thrust is reduced, which in turn extends engine life. Flex takeoff will be discussed in more detail during the performance part of the course. Note: the flex limit and the temperature will be displayed only if a flex temperature has been entered on the MCDU performance takeoff page, otherwise TOGA will be displayed. Today, we will carry out a reduced thrust flex takeoff. Since this is what you will do normally, the first step is to move the levers from idle to approximately 1.1 EPR. When 1.1 EPR is reached, flex takeoff thrust is applied on both engines by moving the thrust levers to the flex detente.
As soon as thrust is applied, the ECAM engine page replaces the ECAM wheel page on the system display. Note: takeoff go-around thrust is always available by moving the thrust levers to the takeoff go-around detente. At thrust reduction altitude, the thrust levers should be moved to the climb detente to select climb thrust. Select climb thrust. No. To select climb thrust, move the thrust levers. No. To select climb thrust, move the thrust levers. When the levers are in climb position, auto thrust is engaged automatically. The thrust limit mode turns to climb, and the EPR rating limit changes.
Two minutes after liftoff, or at 1,500 feet above ground level, or when not at takeoff power, the ECAM engine page is replaced by the ECAM cruise page on the SD. When approaching an intermediate, or cruise level, the EPR will reduce as the aircraft levels off. Watch the EPR indicators. When the EPR value changes from the current EPR to the new EPR value, the EPR command arcs are displayed in green. Let's see this in more detail. Green arcs are displayed between the current EPR and the new EPR value. The green needle corresponds to the EPR demanded by the FADEC. The green triangle indicates the direction of EPR tendency. Note: all these indications are only displayed with auto thrust engaged. When the new EPR value is reached, all these indications disappear.
Let's look at some of the indications on the ECAM cruise page. The cruise page displays the fuel used for each engine, the total fuel used, the oil quantity for each engine, and the vibration rate for N1 and N2. During cruise, descent, and approach phases, auto thrust is normally active, and the thrust levers remain in the climb detente. In flight, if both engines are at idle, an idle indication appears. It flashes for 10 seconds and then remains in steady green. Note: there is a slight difference between flight and ground idle.
If needed, continuous ignition can be selected by turning the mode selector to the ignition start position. When selected, the message ignition is displayed on the engine warning display memo. Continuous ignition is not time limited. Note: continuous ignition may be selected automatically, for example engine flame out detected. No switching action is required. During landing, the pilot moves the thrust levers to idle. This is to disconnect auto thrust and at idle to allow ground spoilers and reverser deployment. Note: as a reminder, a retard auto callout will be generated at 20 feet radio altitude in manual landing, or at 10 feet radio altitude in automatic landing.
After touchdown, reverse is selected immediately to aid the deceleration of the aircraft. Apply the reversers.
On the EPR indicators, reverse appears in amber, indicating that the reversers are unstowed or unlocked. Note: reversers deployment requires 1 FADEC channel operating, aircraft on ground, and thrust lever in reverse position.
When the reversers are fully deployed, the reverse indication changes to green. Select maximum reverse.
As the aircraft speed approaches 70 knots, the levers must be moved to reverse idle. This will be done for you.
At taxi speed before leaving the runway, the reverse control levers should be stowed. Stow the reverse.